Hey, everybody, we'll get started in about 4 minutes. Make that 3 minutes. Good afternoon, Stacy. Good afternoon, Jennifer.
Hello.
Good afternoon, Corinne.
I was going to say, what am I, chopped liver?
I'm going to give everybody another minute or two to see if we can get anybody else. I have a feeling that everyone's in Dr. Young's session or having lunch, one of the two. So I'll start up at 12:17. Okay, so Stacy, Corinne, Jennifer, if you want to unmute at any point, please let me know, or just do so and ask questions. My name is Matt McLaughlin, and this is Everybody is a Math Person, Building Identity in the Math Classroom. So today we're going to talk about that awesome subject of math and kind of the way we work with students. If I could find out, Stacy and Jennifer, what is your role in the school?
I'm a high school learning support teacher starting year 23. And right now my main thing is teaching, co-teaching Algebra 1.
Awesome.
And then I teach learning support, 2 levels of Spanish because I have triple certification. So I teach Spanish class just for learning support kids.
Wow. You sound
Yeah,
like you're
it's kinda
busy.
cool. I am, but it's fun.
Awesome. Awesome, Jennifer. 4th through 6th grade teacher with ES, behavioral and emotional. Awesome. I'm one of the math techs here at the IU. I do math and social studies to give you kind of an impression. I'm the guy, I tend to do the elementary and middle grades math. Corinne tends to do the high school math stuff. We are kind of two members of the math team. And this is something really near and dear to my heart. Identity is so important as we go through, and I'm just going to quickly run through the norms. We are looking at engagement, but all engagement looks different. And we really, if you need to keep your video off, keep your video off. If you want to turn it on, turn it on. If you want to speak, go ahead. I'm not really, there's 4 of us in the room. It's not going to destroy the conversation, and I would like it to be a conversation. So our goal, I'm going to talk to you a little bit in the theory realm, and then we're going to talk about what is math identity, and then we're going to talk about supporting students and teachers into building math identity. So when we talk about math identity, what we're talking about is self-efficacy. And that is the belief that we have in our ability to meet the challenges and to complete things successfully. When it comes to math, in many situations, that self-efficacy isn't there. We have many students who look and say, I'm just not a math person. I don't do math. And when kids don't have that, they aren't successful about that. I'm sure you two have heard people say, I just don't do math. Or we come to the lunchroom, or you're sitting there at the kitchen table, not kitchen table, you go out to eat, and the math teacher's sitting there with a bunch of teachers, and everyone hands them the bill and says, figure out the tip. You understand math. And that becomes like the big thing, is people just don't acknowledge that they are good at math. And I can talk about students in math all day, but the first thing we have to do is talk about teachers. Because math teachers, people who teach math, and everybody is a math teacher, everybody is a reading teacher. We have to get teachers to understand that they can teach math and that they're good at math. And when you have people who don't feel like they're good at math, or they feel like they don't understand math, they tend not to teach as effectively. And that's where we're coming from, is that we have to build both the teacher's efficacy, the teacher's motivation and ability to do math, as well as the students. And this is a whole area of research there, where if the teacher, I've actually been in rooms where the teacher says, I'm not a math person, but I can do this. And the lesson that they're giving to the students when they say that, or when you hear that, is it's okay not to do math. And that's a very scary conversation to have, is it's okay not to do math. And where is this coming from? That's really one of the big things I look at. And I think it's the parents. The parents say, I'm not a math person, my kid's not a math person. It's inherited. They're just not good at math. But what happens is this then breeds that math anxiety. Because if a kid thinks that they can't do it, the greatest predictor of whether you can or can't do something is whether or not you think you can or can't do it. I would rather fall into the I can do it camp and be proved wrong than fall into the I can't. And parents are the primary teachers of students. We always say parents have to teach certain things. Well, this is one of those things that kids learn. They learn from their parents. And when kids learn this from their parents, it is high on difficult to get kids to change their ways. When we have strong efficacy, we have internal locus of control. Right now, so many people are over in this camp, the external locus of control. When we talk COVID, everyone feels like it's something being done to them. When we talk about school, what's happening in schools, your schedule, it's something being done to you. We have no efficacy. We don't feel like we can change anything. We could work as hard as possible, but things wouldn't change. But when we have efficacy, we see that we are the creators of our own future. We are the creators of our own identity, that we can have and we can control things. Where do most of your students end up in this scale when it comes to math? That's a real question.
Middle. Can they be in the middle?
Yeah, it's a scale.
Because I hear all the time, especially with being in high school, parents say, oh, we didn't do this math when I was there. Or I didn't learn this math. I took the basic math. I did, so they're like, we can't help them on this algebra stuff. And then sometimes, they hear that. So that puts them more on the external.
Yep.
Because they're already thinking, well, I can't get help at home.
And if their parents have given up on learning the math, that's hard. Because their parents are their role models. For all that we think they aren't, their parents are their role models. And in efficacy, their peers are also their role models, according to Bandura. And if their peers don't seem to think math is important, which we have a situation where that's happening, and we have this lack of efficacy of their teachers, we tend not to see high levels of teacher efficacy in math till high school. Many of our elementary school teachers, we're just not math people. And they don't necessarily say it to the kids, but they say it to themselves, which impacts how much time they spend on math. It impacts how much emphasis they put in on math. It shows where they make the connections in math. So we may have a deeper problem because it's this whole idea of building a math identity. They don't have the role models who are math forward, especially in special ed and especially in equity situations, that people don't say, oh, these are great mathematicians. You can be a mathematician. And when we look at efficacy, there are two things I'm going to talk about, is that mastery experience and social modeling. Mastery experiences are chances for them to be successful. If you walk into class and every time you walk into class, you are not successful at what you're doing, will you want to walk into class again? Correlate that to the idea that some kids don't have missed something. Why would kids miss something in math class? What are issues that cause them to miss content? You can put it in the chat or you can unmute.
Absences, and language barriers at times. Math, not as much as some other things I teach, but some language barriers, absences, illnesses. And if they miss some of the key stuff because it builds on each other, it makes it harder for them as they move on.
They may never have learned the basics. What kills me is when they pull kids for intervention during core time and the intervention doesn't match what's being done in the class. Or what if they're a perceived discipline problem? They pull them out of class to talk to them, but they're missing class instruction to have the conversation, and then they're put back in the class and they're farther behind, and you have this running trend. Or they're giving special ed services during math and they do pull out during this for the special ed services. And what this does is they lose that mastery experience. They lose the experience of doing well. And so they don't learn that perseverance that they can succeed. They lose that efficacy. They lose the identity as a math person. And they have a greater chance. You can't have a mastery experience without a chance of failure. How many times have you seen the helicopter teacher? They're like flying over the kid, making sure they don't make any mistakes. Kids have to make mistakes to learn. So there has to be a chance of failure for a kid to feel good about what they're doing. So we have to let kids fail at something and then succeed, because that builds the resiliency, or in math terms, if you're using the NCTM practices, perseverance. And we also have to have them overcome disappointment. So it sounds a lot of social emotional there too, is it's okay not to get things right, but we need to have times when they get things right. They also need to see people succeeding who are like them. If they don't see people that are like them that have been successful, they won't be successful in the future, or they won't see themselves as possibly being successful. So when we think about this, let's talk about pull out. If I pull out the same 5 kids every day for math help, what does that tell themselves and the class about who they are when it comes to math? And if you don't see yourself as strong in math, you're in the pull out group. It's like having a reading group, and I remember these reading groups. You had the rabbit, the raven, and the turtle. Well, you're in the turtle group. I'm sorry, you can't read that book. That's not at your Lexile level. When we say to kids, you can't, they internalize. I know I can't do that. I'm in this group and this is what happens. This is my observation. So when we think about math identity, we need a lot of different pieces into it. And when we talk about mathematicians, who are we talking about? If you can give me a name of mathematicians that we talk about in school. Any of them.
Pythagoras.
Pythagoras. Okay. So let's talk about Pythagoras. I'm moving this. Here's Pythagoras. Who else? Yulcid. Anyone else? We sometimes talk about Da Vinci. We can talk about a lot of different mathematicians. What was in common about those three?
Old.
They're old.
Long time ago, old.
Yep. In history, we refer to them as old dead white guys. Think about the examples we give people. When we talk about math, what are the examples? We give them these old dead white guys who talked about math. And they were the ones. And those were the kids. And that's who the kids see as mathematicians. Remember, social modeling means we need to have mathematicians that look like them. We need mathematicians that are like the kids in front of us. So how about these guys? Does anyone recognize any of these guys? Al-Khwarizmi, Aryabhata, Bhaskara, Germain, Anglisi, Gallios, Venmi, Mirskana, Shizi, Al-Hatham, Nightingale, Hypatia, Pingala, Noether, Lovelace, Easley, Brahmagupta, and Uhlenbeck. These are famous mathematicians. We just don't talk about them. Lovelace here is one of the great female thinkers of the Victorian age. Adelaide Lovelace. In here is the one of the main thinkers of algebra. We don't talk about where these things come from. But this is a very different image than Pythagoras and Yulcid. And if we can talk about the contributions of women, of Africans, of Asians, of people of Middle Eastern descent, people of other cultures where we got our math from, this gives them a viewpoint of people who are not like us, that they may see someone that's like them. And the story behind them, being a social studies teacher, one of the keys that we have found, and students love stories. If you can make it a story, you win. If you can make a story that's relatable, that's amazing. One of the classic examples is when we talk to kids about Columbus. Did Columbus know the earth was round? They have known the earth was round since ancient Greece. They had figured it out. The medieval map of the world, I think this is one of the ones of the world. I'll bring it over. There's your world map. It's a globe. The original maps are a globe. The difference is Columbus didn't think the size of the world was correct. He thought it was much smaller than the math told him. He didn't believe the math. But we've always known, they have figured out that it was a globe from some of the most ancient maps. It's not coming up. There it is. That is one of the earlier maps of the world. It's called a T-map. They've known it was a globe. And the ancient Egyptians had figured out the circumference of the world using shadows and geometry. We knew historically this stuff had happened, and we knew that the world was a globe. We don't talk about where this stuff comes from all the time, because we live in this world of we need to get them to understand the 5 different ways we need to add and subtract. But sometimes they'll get the 5 different ways to add and subtract because they'll do it. And when we talk about identity, we're talking about an us versus them thing. What group are you in? Are the kids pro-math or anti-math? We build a group of pro-math people and anti-math people. If you're in this group, you're a nerd because you like math. If you're in this group, you're not a nerd because you don't like math. Or we have you're good at math or you're not good at math. And it really gets into this us versus them instead of saying everybody can be good at math. So we have to build into this question of it doesn't matter. Like, honestly, I have heard Black kids say Black kids don't do math. If you are Black, you don't do math. Doing math well is a white thing to do. That's their perception. That's their social group. So if you're Black and you're good at math, you can't be Black anymore. Talk about attacking a social identity.
Matt, I have a question.
Go ahead.
How do we change their mindset? Like when I have them for algebra, it may only be 90 days and it's high school. So most of the time, by the time they get to me in high school, they're already like, oh, I suck at math. I hate math, da, da, da. How do I change that at a high school level when you have maybe just 90 days?
Tool skills. Instead of, we do instruction where it isn't, okay. I'm one of those people who say, I have 180 days or 90 days to influence a kid. I can cover one skill every day for 90 days. They will get that much of it. Or I can find out what the piece that they're missing is and get them to be successful within the first 10 days and build up from there. I'm going to use diagnostic tests. I'm going to find out what is right beyond them. And I'm going to start there and I'm going to hammer those skills until they got those skills. My goal is to make them as successful as humanly possible in the time that I have. Because if I can make them successful, I can start then attacking this social identity that they are math people. And if I can get them to hit that each time, and I can get them to be more and more successful, I'm adjusting their identity from being not a math person to being able to do math. And having taught in the high school, and I was teaching social studies, but the kids knew I taught math as well. They would come to me and say, I don't get this. can you show me how to do this? And you can change the way kids say, I'm not a math person. And that's the key. Carolyn, that is awesome. It has to be from students. What we know right now is that in most classes, African Americans and Latino students disidentify with math. They don't see it as something that it's something they want. We know there's a racial gap in math scores. I was looking at one source, the NAEP. There isn't a gender gap anymore. There's just a racial gap at this point, or the gender gap is very small. I had a special ed teacher who would say to me, they're special ed, don't expect them to do well. Just have them color. I hated this guy because he set the expectations so low for those kids that they couldn't identify with what we were doing. By the end of the year, they were working closer to grade level with me. This is one of my favorite quotes. We can't embarrass kids, but we can work with error analysis. We can work and have them find the issues and have them have a cycle of being successful. A lot of the ES kids that I worked with, they needed to be successful. The second they saw they were successful at what we were doing, they worked 3 times as hard for me because they could be successful. They knew what I wanted, they knew how I wanted it, and they knew that they could do it. It's not math that kids hate. It's the anxiety that kids hate. It's that fear of math. They have been trained that math is a scary thing. And unlike reading, we don't spiral math as much. If you miss something in 3rd grade, by the time you're in 6th grade, bets are off. We can track a kid's math understanding from 2nd grade, and we can pretty much be assured of what it's going to be in their senior year of high school and whether or not they'll be going to college. So we need to get kids in and identifying as math people very young. And here is some more comments for this. The first, make it relevant to them. Math needs to be relevant to the person who's doing it. One of my things that bugged me to no end is I saw there was a test question on the PSSAs that asked kids how many hay bales fit in a barn. That works really well if you live in the country. If you live in Chambersburg or York City, are you able to even visualize that problem? Is that problem relevant to you? Yeah, they can do the math. We can teach them to do the math. It's a simple volume equation. That's fine. But for you to understand that, you need to know what a barn is. You need to know what a hay bale is. And you need to know that they stack in a barn. Yeah, you might be able to figure it out, but is that fair? Is that relevant to the kids? We also need to really consider how we bring kids into the classroom. When they come in, are we doing warm-ups that have no answer? This drives kids crazy, but it's awesome. Take a word problem, cut it up into pieces, and give kids one more piece each day and have them talk about what those pieces mean. Monday, Tuesday, Wednesday, and Thursday, they get 3/4 of the word problem. Friday, they get the question. They don't get to answer the word problem until Friday. I've given them a chance to think each day. There's no right answer. There's no wrong answer. No, that every answer is optional. If I can get a kid just to talk math, suddenly they start seeing themselves as a math person. Or, this is one of the ones that I tend to use. If you've ever seen this site, you do a estimation 180. I don't know if I went, there it is, day 191 of estimation 180. Let's see what I'm estimating today. Looking for a day. Oh, let's do 21 to 40. How many folders are in the box? We can zoom in, we can see that they're hanging folders, they're about this thick. We can come over here and see that there's 100 folders in here is what it says. How full is the box? And we can have a conversation about the estimation. If the kid says 179, that's their choice. That's their answer. There is no one answer. Another great site is Which Does Not Belong. I can give you, I want that one, these 4 numbers. I asked the kids which one doesn't belong. Me, I think it's 43 because 43 is prime. Or maybe 9 doesn't belong because I just like the number 9. That's an answer. Or these 3 are all perfect squares. I can come up with a number of reasons. 9 doesn't belong because the digits and all the other ones add up to 7. $16 doesn't belong because it's the only even one. There are tons of different items. 9 because it's single digit. These are an amazing resource. And if you go to the source of wodb.ca, you can find graphs and equations for your algebra kids. And you can have algebraic conversations. And they can look at all of these and see what they are. And I don't care if they are great. I don't care if their answer is, I think this one doesn't belong because it's blue. That's fine. There is no wrong answer. And that's really the key with these, is we want to do things that have no wrong answer because we want kids to be successful. And we want them to know that they can be successful when they do math. And that builds the concept of being a mathematician with them. We also want we want them to work in groups. Have them solve equations in groups. Have them do group quizzes where all they have to do is participate and show that they're participating. You're going to see I don't care. Getting procedural methodology is great, but if I can get kids to talk math, I can get them to get the conceptual understanding, which is going to go farther in the long run than just getting them the steps. One of the things, Stacy, for COVID end, breakout rooms in Zoom. And then I would have the kids do it. Let's see, did I put it in there? I might have them do a breakout room with a Jamboard. Have you used Google Jamboards? I like Jamboards for the collaborative nature. Let me see if I can go to one of mine. We use them when we're planning things out. So I may have a Jamboard that looks like this that I give kids, and they can put in Post-its, and each kid could have a Post-it about how they would solve the equation, or they could have a Post-it about what they're thinking. And it does spell check for them. And they can put their Post-its in. You can use the pen to draw arrows. It's basically a whiteboard, but it's a collaborative whiteboard. And so if you're using Google, you can create a number of these and have them preset up for your class. And so you tell each kid, each group, I want you to go to this Jamboard, or I want you to go to that one. When I was assistant, the teacher used them.
So we can like take that link and put it in Schoology for them to get on. They could click on the link.
Yep.
Okay, and then they could all get on, like I could have them in groups or whatever and say, okay, this group's going to this Jamboard.
And you see that up here it has Jamboard 1 of 3. I might go to the first Jamboard, go to the second, go to the third, go to the fourth,
Okay,
and have
so
each group working on a different one. The other thing is a status intervention to change what they think. The status intervention I'm thinking is positive targeted feedback. The kids that really don't see themselves as math kids, you make it so that you make sure to talk to them about math. You make a point of going to them and reinforcing that they are good at math. Because you need to target that feedback, and it has to be real. It has to be honest feedback. Like, I've seen teachers give kids, oh, you're really good at this. Yeah, that's not going to help anybody. Give them targeted feedback that they can do certain things. The more we do that, the better our feedback is, and the better the kids internalize that feedback. If you walk in every day and someone says you're good at math, you can blow that off. I like how you use your reciprocals here. That is exactly what I'm looking for when we're doing this. Or you explained that piece extremely well. Could you explain it to the class? Being very specific about feedback makes it more impactful. I don't know if you guys are married or not, but I make, like, when someone gives you a compliment, or your husband or wife gives you a compliment, your significant other, you want them to explain what they want, what they like, not just say, you look nice today. I like how that sets off your eyes. That has a whole lot more meaning then you look nice. And that's really the key here, is that real feedback for kids. Because how often do we really give them, I can write good job on a paper, that's great, or on a test. But if I circle one piece and say you did this excellently, or I like how you did X, Y, and Z, it takes me an extra minute. It means the world to the kid. And high schoolers love that type of stuff. That and stickers. It's really fun, high school and stickers. Positive math talk. I made it a rule in my math class that people could not say they didn't know how to do math. It became the rule. I would flip out on kids. I also can go to 100 and then back to 0 in seconds. But I would flip out on kids jokingly, but still do it, to make sure that they talked positively about the math that we were doing. When they said, I don't get it, I would flat out say, what of it don't you get? And if they said the whole thing, then we would start with, okay, what is the number you don't get? Well, I get the numbers. So what about the signs? Well, I get the signs. And I got them to start acknowledging that they understood parts. And then we would get down to the part, well, I don't understand this one piece. I get them to identify where they weren't getting things, instead of saying, I'm just not good at this. I'm not good at that is an internalization of this is hard. I don't understand this piece is them saying, I can do this. It's that internal locus of control. I can do this up to this point. There's a big difference there. And building a math culture means talking math. It means being math. It means doing math things and waking kids up that math is everywhere. Poetry has math. The best music has a formula to it. Some of the most famous 80s songs have 3 chords, repeated over and over and over again. The best parts of music are mathematical equations. You can put music together through math to understand where the harmonics are. Math is in everything. So something that I believe strongly about is that anyone can be a math person. I am a big believer of supporting kids and trying to get them to recognize their identity and their multiple figure and show them multiple figures in math. We need to socially accept math and math instruction. It is not okay not to be a math person. And that's key. And in the school itself, praise math and math accomplishments as much as we praise everything else. I believe that identity is formed in so many ways by how society sees things and the culture of that society. I hope, and here's a bunch of the links for the articles that I was using to find this. The one question you asked me, Stacy, about how do we fix it, has the least research to it. But there is a gentleman, and I do suggest you follow him on Twitter, Robert Berry III, Robert Q. Berry III. He's a past president of PCTM at this point. This is an old site. He has started the hashtag Black Kids Do Math. And a lot of his work is based around, there is his NCTM, there's his Twitter page. A lot of his work is around this concept of math identity and getting kids to talk math. But it's at Robert Q. Berry is his Twitter handle. Do you have any questions or comments or thoughts? There's one of his latest things that he's been doing. Thank you so much, and I do appreciate your work with students in math. I know it's hard sometimes. I know fighting the math identity of I can't do it is always feels like an uphill battle. I feel like I play whack-a-mole when I do it. But as kids, the more we do it, the more kids will identify as math people and can really find the love of math.
Thank you, Matt. Can I get on that math coaching network that you guys were discussing in
Yes.
the virtual setting one?
If you want to, that's my email. If you shoot me an email, I'll get you on to our math coaching.
Okay.
Part of being part of that network also means you get all the advertisements for all of our math stuff.
That's fine.
So all of our
yeah.
math sessions that we run at the IU, you'll get notifications that we are doing different PD on math. So I'm just warning you guys, we do our best not to spam everyone, but if it has a math thing, we put it through the network.
Okay, thank you very much. And I took a lot of notes on this. I think there's some things I'm going to talk to my co-teacher about adding in for this year.
Great. I hope you guys got something out of it, and I'm going to let everyone go about 10 minutes early, so you have about a 25-minute break this time. Jennifer, Carolyn, do you need anything before I shut it down?
Nope. I think the only piece that I keep just wanting so bad is that universal screener for our kids.
Easy CBM is a quick one. It is free and it is online.
Can you say that again?
I put it in the chat. Easy CBM.
Okay.
Universal screener wise, I'm looking for a number of them, and I will continue putting it out there. If you shoot me an email, Carolyn, I will send you all the ones that I know about.
Okay.
There's not a lot out there for universal screeners for math.
Why is that when, like, I think all the, the presenters and, everybody's saying research-based, it has to be research-based. It has to be, which I totally get, but nobody has come up with one for math. That is, so, like, I look at math, like I look at reading, and everybody uses, everybody has one for reading, but math, it seems to be the lost component where it's as equally important as the reading.
The reading literacy research really began in the 60s and was pretty much settled by the 80s about what is the science of reading. So that really makes it easy because we know how people learn to read. Kilpatrick with the reading rope and the elements of math not the reading rope, the math rope and the elements of a high quality math instruction is 2001. The research is much thinner on the ground in understanding how students learn math than it is in how students learn reading. Okay. So we don't have as depth of the research doesn't have as much depth. So what ends up happening is we don't have all of the screeners. Acadience has some good screeners for math. And they'll give you a lot of information. And that is something that we can talk about. Though Acadience Like it's run the same way their reading stuff is run. So if you've ever given the Acadience metrics for
Yeah.
reading, they
Okay.
have the same ones in math.
Okay.
Easy CBM is a online version kind of, and it gives you some of the same stuff. I like it because it's online right now and you can use it as a screener. But I am also a big fan of Acadience. Let me see. I'd have to go look at my list. It's been a bit since I had the summer a little bit off, so I haven't been staring at my paper with all of the
That's okay.
screeners on it.
It's okay. I'll just email you and see the list. Thank you.
Not a problem. Thank you again for coming, and I hope you all have a wonderful day.